Let us discuss the limit of a function and how to evaluate for some examples. Limit of a function. Suppose we have the function like this, and this is a point A and corresponding value as f of A, right? So before going to discuss limit, we need to know about left hand limit and right hand limit. So what is the meaning of right hand limit and left hand limit? So we have to, for the left hand limit, we have to approach the values of x from the left side of A. That is, we have to move the values from left to right. So from the left side. So left side of A, you have to increase the values x, slowly increase the value and approaches the value A. Then what will happen? Correspondingly, the function slowly increases and approaches this value f of A. So when x approaches to A, correspondingly f of x will approaches to f of A. Then we can say that left limit of f of x is f of A. That is, limit extends to A minus f of x is equal to f of A. This A minus represents left side values of A. Similarly, for the right hand limit, you have to approach the values of x from the right side. That is, right to left. You have to move like this for the left hand limit. For the right hand limit, you have to move this right to left. For the left hand limit, you have to move left to right. Okay. So you have to take the values of right side of A. And what will happen? Correspondingly, the function slowly increases and reaches this value f of A. So then we can say that limit extends to A plus f of x is equal to f of A. So when the limit of a function exists, when LHL value is equal to RHL value, then we can say that the limit of a function exists. So if LHL is equal to RHL is equal to some L, then limit extends to A f of x is equal to capital L. Otherwise not. If LHL is not equal to RHL, then this is not equal to capital L. For limit of a function. So suppose I want to evaluate limit extends to 0 mod x by x. This is a little complicated function. So I'll rephrase the definition of RHL and LHL. So what is RHL? Already we know that limit extends to a plus f of x. And LHL is nothing but limit extends to a minus f of x. Okay, so for this we have to approach right side values of a plus h for x, right? So for the function, this is a point A. For finding RHL, we have to approach the right side values of A. For finding LHL, we have to approach the left side values of A. So these points are nothing but A minus h, and these points are nothing but A plus h, right? And then you have to slowly approach us to A. So then what I can write is h tends to 0. And similarly, A plus h will slowly approaches the value A. So h tends to 0, right? So we can make it limit h tends to 0, this right side points of A, so x will be replaced as A plus h. And similarly here, limit h tends to 0, f of A minus h. Okay, so because of left limit, we are approaching the points of we are approaching the points left side of A, therefore here it is A minus h, and here we are approaching the points from the right side, therefore it is A plus h, and we have to slowly move A plus h to A, therefore h will be goes to 0. Similarly, from the left side A minus h to A, we have to approach A minus h to A, therefore h approaches the value 0. Okay, so I can replace this RHL is equal to limit h tends to 0 f of a plus h, and this will be equal to limit h tends to 0 f of a minus h. I'm going to use this definition for finding the limit of this function. So for finding LHL, limit h tends to 0 f of a plus h. So here a is nothing but a is equal to 0. For this problem, a is equal to 0. So this is nothing but limit h tends to 0 f of 0 plus h, right? So this equal to limit h tends to 0 f of a plus h using the given function modulus of 0 plus h divided by 0 plus h, which is nothing but h by h is equal to 1, right? And then for RHL, limit h tends to 0 f of a minus h, that is limit h tends to 0 f of 0 minus h. So this equal to limit h tends to 0 modulus of 0 minus h divided by 0 minus h is equal to limit h tends to 0 minus h by h, h by minus h, so I'll get minus 1. So RHL value is equal to 1, LHL value is equal to minus 1, RHL is not equal to LHL, therefore f is limit of f not exist at x is equal to 0. Limit of f not exist at x is equal to 0. Okay. Next problem, limit x tends to 3 mod of x minus 3 divided by x minus 3. Similarly, you can approach finding LHL. Limit x tends to 3 minus f of x is nothing but limit h tends to 0 f of 3 minus h. So which is equal to limit h tends to 0 modulus of 3 minus h minus 3 divided by 3 minus h minus 3. So limit h tends to 0, numerator will become h, denominator will become minus h, it is minus 1, which is equal to minus 1. So RHL next, limit x tends to 3 plus f of x is equal to limit h tends to 0 f of 3 plus h, which is equal to limit h tends to 0 modulus of 3 plus h minus 3 divided by 3 plus h minus 3, which is equal to limit h tends to 0 h by h, which is equal to 1. So again LHL is not equal to RHL, therefore limit of f not exist at x equal to 3. That's it.